Hello. So today we're going to be doing rotate list. Given the head of a linked list, rotate the list to the right by k places. Um, so it's not like a so rotating left would be, you'd be going 1 to 2, and that'd be one rotation, and then 3 would be another rotation. So since it's rotating right, essentially like a reversed version. Um, so it's a little bit harder than rotating left, but still not very difficult. And yeah, so what we're going to do here is if head is none or head.next is none, then you return head, because if there's nothing or there's only one node, there's nothing to really rotate, right? So we're just gonna return head and basically finish the problem there. So now we need to do two things, which we can do at the same time. One is get the length of the list, just so we know how many rotations we would need to actually do. We'll be using it for a calculation that will help us determine how many how many rotations we need to do to the list. And another thing is we need to combine the tail or the last node to the first node, just so we have a cycle and we're able to actually essentially infinitely rotate. So here what we're going to do is calculate the length. So we're going to have a length variable at 0. We're going to have a previous and current starting at none and head. This will get us to the point where, since current starts at the head and then previous starts at none, because it starts at nothing, and once we hit the end of the list where current, while current is not none, basically once current is none, that means previous is at the last item, right? So we will be accounting for every item in the list, or in the link list, and then so we'll have our count, which is correct, and then we'll be able to connect previous to the head, right? So here we're going to do length plus equals 1, which helps us increment the length. Previous is equal to current, and current is equal to current.next. And so like that, we're able to calculate the list, and at the very end, previous will be pointing to the tail of the list. And from here, previous.next is equal to head. And now we've created our cycle, right? Now we need to calculate how many rotations we actually need to do. Because let's just say for this example, actually no, we'll use this example because it shows what I want to demonstrate, which is, since we want to rotate 4 times, but the length of the list is only 3, by rotating it 3 times, we'll be back at the base list, right? So there's no point in doing these first few rotations, like these rotations, because the result would be the same, right? We can essentially go straight from here to here, or like if you block out the top 3 right here, it'll be like here to here, but this would just be rotate, the no rotates, and this would be rotate 1, right? So in order to calculate that, we'll be doing rotations is equal to k mod length. So this does division, but it gives you the remainder, right? So for this length is 3, which we would have calculated here, and 4. So then we'll do 4 divided by 3, which remainder is 1, right? So that means we just need to make 1 rotation, because if you look at the answer, rotate 4, the answer is 201. It also says right here 201. From 0, 1, 2 to 201 is 1 rotate, or like to the right 1 rotate, right? So we can use this to calculate it, and then just to prove that the math does work, with this 1, 2, 3, 4, 5, length is 5, k is 2, 2 mod 5 would yield 2, and so we do 2 rotates here, right? And so since rotating to the right is not as, I suppose, intuitive as making since rotating to the right is not as intuitive, because since you see how the tail comes to the front for 1 rotate, like the intuitive rotate would be 1, and then the next one would be 2, 3, 4, 5, 1. That would be the intuitive rotate, right? But since we're not able to do that, we need to like make a modification to that. So we're going to have to skip nodes is equal to length minus rotations. Because here we want to, since it's like the essentially like a reverse version, right? So since with the intuitive rotate, in order to hit here, we need to go from 1 to 2 to 3 to 4. That would be 3 rotates, right? Like if you rotate once, it would be 2, rotate another time would be 3, rotate another time would be 4. Like that would be an intuitive rotate. But since we're doing like essentially the counterintuitive rotate, we need to do the reverse version where we just take the length minus rotations. And then, so from here, we want to hit the node where we want to hit the node right before where we want the new head to be. It's the same logic with like this previous and current logic, right? So we're going to start with current is equal to head. For I in range, since like it's not, since we don't want to stop on a condition where it's none because there is a cycle or like any other condition, we can use a for loop since we know the amount of oops, I think that's one too many underscores. Skip nodes minus 1. So if we go to skip nodes, or like for I in range of skip nodes, then we'll be at the node where we want we would be at the node where we have the head, the new head, but we actually want something different because we want the one right before it because the new head, like, so 3 would be pointing to 4 here, right? So if we stop at 3, we can get a pointer to 4 because it's just the next thing because it's, you know, they point forward, and then we want to make sure this next points to a none, right? So, well, actually, I kind of jumped ahead of myself. This part, we just want to keep iterating until we're at the node right before. So here we want to stop at 4, or like we want to stop at 3 because our answer is 4 and we want to break the cycle, right? So here we would have stopped at 3. And then so our result would be current.next, right? Because we need to get a pointer to this before we break the existing record. So current.next is now equal to none, right? Because we want to break this link between 3 and 4. And then here we can just return result. And to show that the logic works the same here, 0, 1, 2, k mod 3 is equal to 1. And then length of 3 minus 1 is 2. And then so we want to do 2 rotations, like 1, 2, but then we want to stop before 2, right? So we'll stop at 1. So we'll essentially skip 1 node. And so from here, current is equal to head, right? To none, to next, which is 1. And then so now we have where current is equal to 1. Now result is current.next, which is result here, which is the 2, right? And then current.next, which is 1.next, is now none. So it's 2, 0, 1, right? So which is the answer right here. So just to make sure, the answer does work. It does. So yeah, thank you for coming. Hope you enjoyed the video.